Assalamualaikum and hi everyone. My name is Fahmi and today I'll be doing my PSM1 full report presentation. Now, the topic that I'm presenting is called Comparative Study on the Performance of Sequential and Non-Sequential Deep Learning Model for Phishing and Phishing Email Detection. Again, so here are the things that this is the things I will talk about. We touch a bit about the introduction, the background problem, what is our aim, what is our objective, and what is the scope of this project. And then we're gonna go to chapter 2, where we're gonna briefly talk about the literature review that exists within this sphere, and then the deep learning models that we choose, what is the research gap, and what is the focus of our study. And then we're gonna talk about research workflow in our chapter 3, and then the data set that we chose. And then we're also gonna talk about data pre-processing and performance measurement. And last but not least, we're gonna go for chapter 4. We talk about experimental design, what are the hardware and software they use, and then lastly in chapter 5, we'll talk about what are some of the achievements that we already have and what is our future study in FYP2. So to start things off, phishing is a type of network attack in which a threat actor, or like a hacker or something, obtain your user information by creating a fake website to impersonate trusted authorities. That can be a police officer, that can be a bank. It combines two methods: a social engineering method and also a technical means. So these two combination is what makes phishing attack is very deadly, right? And the most common medium phishing attacks is email phishing. There are smishing, there are phishing, there are different kinds of phishing attack, but the most common one is email. Now, to talk about the background of this problem, first we have to realize that the traditional method that exists right now is not very effective. All right, because now the threat can use artificial intelligence to generate emails that contain phishing content or spoof their domain. Right, in some ways that the current traditional method is very limited. For example, like blacklisting. Right, blacklisting method is not very efficient when it comes to handling the current threat or phishing attack. Now, the second thing is the financial implications. So, for example, in 2018, the FBI suffered around 100 million USD of loss due to a compromised payroll database that resulted from a phishing attack, right? And then last but not least, there's a challenge in feature engineering and dependency on external service. This is geared towards more machine learning, right? Many phishing detection systems really rely on manual feature engineering and or third-party services, which means like they need an expert to predefine first, what are things that can or cannot be considered as phishing attack. But the problem is the landscape is always changing, so they're not very dynamic to adapt to the current growth, the current landscape that exists in phishing. So they're kind of very static, right? Now, what is the research aim? Now, most of the research that's been done when it comes to phishing, they're focused more on the comparison study between, let's say, supervised, unsupervised, or hybrid dealing models. Or maybe they just focus on one specific model, like CNN or LSTM, and they just try to analyze the performance of that model when it comes to detecting phishing email. But there remains a gap when it comes to understanding the comparative analysis between two delivery model of sequential and non-sequential model, especially when it comes to phishing detection. The objective of this research is first is to pre-process email dataset, because we know that dataset that we get online are rarely pure by any form. So they're kind of not dirty, but they have a lot of noise. So we have to clean them up so that our model can learn to the best of their ability. Now, second thing is you want to develop and train both sequential and non-sequential model. And thirdly, you want to compare the performance of these two model using the same metrics like F1 score, accuracy, precision recall, and so forth. Now, the scope of this project, we're not actually creating a new solution. No, we're not. We are just comparing the effectiveness of four models together, right, head to head, right? And the data set that we get mostly from Kaggle, which often include the email content and some metadata like the subject, the header, the content of the email. And these data set usually are being labeled as either phishing or not phishing, right? So let's do a bit of literature review introduction. Now, generally, there are three kinds of phishing attacks. The first is disguised email, where an attacker, again, like I said, use a guide emails to send emails disguised as as trusted authorities like police or bank officer or HR manager, something like that, right? Second thing is email loophole, where like a malicious script is executed immediately once you open the email. It's almost like zero data. The third one is called hidden attached file, where you download a file from an email that you got, and then that file can somehow be a backdoor to the threat actor, or they can install keylogger without you knowing on your computer, of course. Now, there are four deep learning models that we choose for this. So the top two is sequential. The bottom two is non-sequential. Okay, so LSTM is well known for their ability to process large amount of data, independently learn and understand complex feature of the data set. Usually we don't use a base level LSTM. If you understand, if you read a lot of research paper, they don't use raw LSTM. They kind of use like maybe by LSTM or CNN dash LSTM. So they always have some form of hybrid modified version of LSTM. But that is something that we will think of later on in FYP2 now, or maybe in FYP1, second thing is recurrent neural network, RNN. It's a useful tool in understanding NLP, video classification and speech recognition, as they utilize contextual information. The two non-sequential model that we choose is MLP and FNN. MLP is very useful in static features, something that doesn't change. The URL pattern really doesn't change over time. How URL is set up is how it's going to be for the next 10 years, okay? And then FNN is something like MLP, but it has like usually like one single layer instead of multiple layer. That's why it's called multiple layer, right? So again, like I said, what is the research gap and study focus of this thing is that we understand that there is a gap within the research field, that there's not been a lot of understanding between the comparison of sequential and non-sequential model, right? And so given this architectural difference, because how sequential and non-sequential model operates are kind of different, because sequential in some ways, the input of the orders matters, right? So they take into account semantic understanding and grammatical idea, but non-sequential do not care about those things, all right? And so it doesn't matter if the sentence is grammatically wrong. They're just gonna see things as individual. Okay, so because of how these two architecture are widely different, we are asking the question like, could that mean the difference between what's good to be applied for a real life system and what's not good to be applied, right? And so this is our research workflow. We can divide it into roughly three phases. The phase one is data generation pre-processing. First, we collect from publicly data from publicly available repository like GitHub or Kaggle, and then we process them and we standardize them. I'll talk about it later on more. And then we feature extraction them. Maybe we can apply like TF-IDF, so that TF-IDF is something like it calculates how often words occur, and it treats every word that occur in the email as equal, right? So maybe phishing email often have the word like urgent or free, and those words might have higher frequency, right? And then after we have processed them, we will save it to a CSV format file, and then we will split them to training and testing. I have chosen 80% of training and 20% of testing. And then phase two, we talk about the model implementation, how we train the model. And the phase three is where we test the model, we evaluate the model, right? And then we do a comparison on their performance. This is the data set that we choose. Now you can see that there's a word baseline there. What does that mean, right? So usually when you want to choose a data set, it is a good recommendation that you choose a data set that other researchers have chosen. All right, so that in some way set a baseline for your data set, so that the other two data set that you get, or the performance or the result of those things, can be compared to the baseline result, right? And so the most common one that I found is that a lot of researchers use Nazario Phishing Corpus. It's a kind of old data set, I can't deny. And it's a very small data set relative to the second data set, which is like 82,000, The first data set is imbalanced. That means that the number of ham experiments are not equally 50-50. It's not exactly 50-50, but it's not exactly 50-50. And so as you can see in all these three data sets, we kind of varies a bit in our choice. We choose like data set that have large number of values in them, like 82,000, and some are like just 1,000. We choose like imbalance, and we also choose imbalance. Now, why do this? Because by doing this, we are training our model to be more robust, all right? So that it detects a wide variety of data, right? So you're not just focused on one set of particular, or which is a feature of the data. They're not only trained on balanced data set, they are also trained on imbalanced data set. Let's see how they do when it comes to imbalance and balance. So those are the things that you want to put up against on our models to see how robust they are in dealing with this kind of issue. This is a data pre-processing. Like I said, there are many ways how we can pre-process the data. Again, like I said, when you get a data set, it's kind of noisy, it's kind of a lot of noise in it, and you don't want them, you want to clean them so that your model can train them and understand them and learn them a bit better. You can use lower casing method, where instead of everything in capital, you just make everything lower casing. You can remove HTML tag because, well, they pretty much have no use whatsoever in understanding the context. You can use stop word removal. Now, this is particularly, you have to be very careful, because like if you remove stop word removal like is or are or n, a sentence can broken up in terms of grammatically. All right. Now that's okay for non-sequential because they don't care how the input come in, right? But for sequential, that could be a problem. So stop word removal have to be dealt with very care, depending on what model you are using for. And last but not least, tokenization, where we convert like words to in simple terms, we convert words into numbers. So let's say Adam went to the shop. Adam may represent number 0, and then when maybe represent number 3. And so the computer doesn't understand Adam went to the shop. It understands 0, 3, 15, and 9. So that's how they understand it. Okay. So now is the performance measurement. There are 4% performance measurement generally. Okay, that's the other two also. But this is the formula that we have: precision, accuracy, recall, and effort score. The other two, if I'm not mistaken, is actually the time and also the how it resource, because we also want to see that it doesn't matter how well a model learn, but if they consume a lot of time and they consume a lot of resource, then it's not very, what would you say, if it's not very applicable in real life system. We want something that's fast, and we want something that doesn't consume a lot of hardware resource of the machine that you are using. Then we have the experimental design. Like I said before, we split the data into 80-20, and then remember how I said that we have imbalanced data set. Now there's some ways how you can make them into a balanced data set. We can use smart, you can use oversampling. So smart can be like synthetically generate data from a dominant class. Oversampling is where you take a non-dominant class, non-dominant class, and then you oversample them. You create more of them in that class. And then we have the third process is sequential mode using Keras tokenizer. Again, like I said, I want to use the Keras tokenizer, and then for non-sequential, use BPE because we can't use Keras tokenizer for non-sequential. And then lastly, we have feature engineering, where we use TF-IDF as for preprocessing. This is the hardware and software that we will use for this research. Now, some of the achievements that we have in PSM1 would say, first, we identify the ongoing challenge in phishing emails realm in the domain, right? And highlight the literature review that already exists. All right, and what are the limitations of current methods? What are the limitations of traditional and machine learning methods, right? And then we finalize the research methodology structurally into 3 very constructive phases. We have the data preparation phase, model development, and performance analysis. So this 3 phase is something that we're gonna have to follow rigidly later on in PSM2. Now, and then we design tailored data preprocessing workflow. For example, we use tokenization and then HTML tag removal, stop handling. All of these methods will actually make our data set more better, and in some ways, allow our model to learn better. So for future study of FYP2, what we will be doing in next semester is actually to refine phishing detection by pre-processing dataset first. We have to pre-process it first, right? By removing noise, by tokenization, and then put feature engineering, and then we train our model. And then after we train, we will evaluate each model using the same metric: accuracy, precision, recall, effort score, hardware utilization, and time utilization. And the last but not least, we will make a comprehensive comparison: who's better and who's not, who's consuming more resources, who's consuming more time, and so forth. Those are the things that we will evaluate. So that is pretty much a brief. That's pretty much a complete report on my PSM1 for this chapter, for this semester. I hope I'm able to deliver what's needed. And so with that, I'll see you again. Thank you so much.